Good morning, guys. Today we're going to just do a quick review of the two sections we've already covered, solving the system by graphing and solving the system with substitutions method with some simple examples. You've already got plenty of examples to work with. You have IXL strands under Algebra 1 of U.2 and U.4, which some of you did not complete. A little disappointing. But that's practice for you if you want to go back and do some more. There will be a quiz posted tomorrow. When I post the quiz tomorrow, I expect you to get it done as soon as possible. It is due by the end of the day, no later than midnight. I'd rather you don't wait that long, but that's when it's due. Do not be late. Please get it done on time. For our review today, we've got a simple graph problem to solve first. So, solve by graphing. And this one says y equals negative 2x plus 4, and x plus y equals 3. Well, I know that one of them is in slope-intercept. The other, of course, is not yet, so we should put that in slope-intercept so we can graph it. I'm going to subtract x from both sides, and now it's in slope-intercept form. Well, that's handy. Since I've done that, I'm just going to erase the other form because it doesn't help me. And now I have two lines that can be fairly easily graphed. Now again, I advise you to print some grid paper. I'll attach a grid paper template to this assignment as well so that you'll be able to print it out if you can't find any or just don't want to look. But I'm just going to do one on the board and hope for the best. Now the first line has an intercept 1, 2, 3, 4. And it's got a negative 2 slope, which means it goes down 2 over 1. So I'm going to go down 2 to the right 1. I'll do it again. Here's my line. Again, my hand-drawn grid, not perfect, but there's what I'm looking at. So far, so good. Now, the second equation has an intercept of positive 3 right there, and a slope of negative 1. Down 1 over 1, well, that's nice and convenient. It looks like it's right there. And if I were to connect them, looks to me like that's the coordinate of the intersection, and I'm going to go with it's 1, 2. I drew it by hand. I can't trust that what I draw by hand is accurate. So how can I actually verify my answer is correct? I can plug it in. Does 1, 2 as x and y get me a correct statement in both of those equations? Well, I'm going to plug in 2 for y. Does 2 equal negative 2 times x is 1 plus 4? Negative 2 times 1 is negative 2, and negative 2 plus 4 is 2. That worked out on that line. Do it here as well. Plug in 2 for y and 1 for x. Is 2 equal to negative 1 plus 3? Well, 2 times negative 1, 2 equals negative times 1 is negative 1 plus 3. That certainly works. There's no issue there. My answer is 1, 2. Do not tell me the answer is one solution. Do not stop with one coordinate, and you do have to check the answer to make sure it works. The solution is the coordinate 1, 2. If I asked how many solutions will there be, well, sure. Now you could say there will be one solution. And furthermore, it is at the coordinate 1, 2. Moving on. All right, the next ones we're going to do with substitution. So let's try this problem here. We have y equals negative 2x plus 4. And I'm also going to give you x plus y equals 3. Well, that looks awfully familiar. Why does it look so familiar? We just solved it with graphing. We know the answer should be 1, 2. Let's make sure it actually works with substitutions as well. You can either put this in slope-intercept form and make it equal each other, or you could plug in negative 2x plus 4 in place of y. You're probably going to have an easier time along the way just by putting them both in slope-intercept and setting them equal. However, it depends on the problem. I will do that here. I'm going to subtract x from both sides. So once again, I have y equals negative x plus 3 And now because they're both in slope-intercept, they both say y equals, I'm just going to set them equal to each other. Negative 2x plus 4 equals negative x plus 3. I'm going to add x to both sides. Please stop making mistakes right here. Negative 2x plus 1x equals negative 1x, or just negative x if you prefer. This one canceled out. Now what? Well, now I'm going to subtract 4 from both sides. Negative 1x equals 3 minus 4 is negative 1. And now I divide by the coefficient of negative 1, and x equals 1, which we already knew from the graph should be the case. All right, I'm not finished. You can't end there. We're looking for the coordinate where they cross. I only know the x value. I'm going to plug it in right there. Y equals negative, parenthesis, 1 plus 3. 1 because x is 1. That means y equals negative 1 plus 3, so y equals 2, which again, we knew it should from the graph. So what's my answer? The coordinate 1, 2. That's my answer. That's where the two lines are going to cross. It agrees with the graphical solution, which we already found. We're good to go. There are also special systems, which we've talked about several times now. Special systems are those in which there is either no solution because they are parallel lines, or infinite solutions because they are the same line. Obviously, we'll do one of each. Here's one special system, 2x plus y equals 10, and also y equals negative 2x plus 4. Again, you have your option. You can either substitute negative 2x plus 4 in place of y, or you could set them both into slope-intercept form and solve that way. It's okay if you want to do the slope-intercept form. So subtract 2x from both sides. This one's already in slope-intercept. I can see that they have the same slope. I can see that they have different y-intercepts. What does it mean when they have the same slope but different y-intercepts? That's right, they're parallel. Parallel lines will never cross. Can you solve it mathematically? Sure, let's keep going. Set them equal to each other. Negative 2x plus 10 equals negative 2x plus 4. Again, I already know it's a special system. What do I expect to happen in a special system? I expect the variable to drop out, and the numbers remaining should either be true or false, and it's going to tell us what kind of system it is. I'm going to add 2x to both sides, and in this case, they will both cancel because negative 2x plus 2x is nothing on both sides. 10 equals 4. Well, there's no variable, and the answer is false. What does it mean when the answer is false and there's no more variable? It means that there's no solution. What kind of lines have no solution? Parallel lines. Okay? Make sense? And again, from the equations, we already knew they were going to be parallel. They have the same slope and different y-intercepts. Moving on to our last system. And if you've been paying attention, you already know what kind of system it's going to be, but let's just do it anyway. 2x plus 4y equals 8. Y equals negative 1/2 x plus 2. I already put one of those lines in slope-intercept. You could put the other one as well in slope-intercept, or you could substitute. I've done enough of slope-intercept. I'm going to substitute this time. I'm going to plug this chunk of information in place of y. 2x plus 4 parenthesis, negative 1/2 x plus 2 equals 8. Again, this is the alternate way to solve these kinds of problems. I'm going to distribute my 4. I get 2x. 4 times negative 1/2 is minus 2x. 4 times 2 is plus 8. And it says equals 8. 2x minus 2x. Well, that's nothing. They're on the same side of the equal sign. We just combine like terms. 2x minus 2x is nothing. So they drop out. I'm left with 8 equals 8. No variable. True statement. What does that mean? Infinite solutions. What kind of lines have infinite solutions? The same line. Those two lines were actually the same line, just in two different forms. Slope-intercept and standard. They're the same line, though. Infinite solutions, they cross everywhere. All right, so as far as our review goes, that is it. All right? There's no additional homework. What you ought to do is watch the videos again if you need to. You don't have to. But if you didn't watch them in the first place, please do. There will be a quiz posted tomorrow morning. It is due tomorrow by midnight. Please get it done on time. I have to take points off for lateness. There's no reason to be late. If you're actually logging in every day to log your attendance, you should be actually watching the videos and doing the work as well. So I need to see that's happening. Okay? Have a wonderful day. Let me know if there's any questions. Thank you.